Think about this picture: an arrow flying, but it's still every moment it moves. How can this be? This is Zeno's arrow paradox. Zeno said if an arrow is still every time, then motion can't happen. This is a mystery about time and movement. It makes us ask if time is just something we imagine.
This is interesting. Zeno's puzzles are deep questions. Physics today, like quantum mechanics, offers new ideas. Quantum says particles can be in many states at once, which changes how we think about motion and time. Was Zeno onto something that science is just discovering now?
Exactly, Guy. And think about what fast cameras can do. They can take pictures of motion in tiny time bits. Each picture shows the arrow in a new place, showing motion, not stillness, like Zeno said. Do these new tools solve Zeno's puzzle by showing proof of constant change?
That's a good point, Ryan. But let's ask what a moment is. If time is made of tiny moments, each one showing a still picture, how do we see smooth motion? Maybe Zeno's puzzle shows that our senses can't always trust the real world. It makes us think if our sense of movement is more in our minds than real.
Let's think more about this. What if Zeno's puzzle is not to say motion is impossible, but to make us rethink time and existence? If an arrow is still at every point, are we missing something about time moving and how we feel it? This puzzle might make us explore if time is just something our minds create. Can new physics theories help us understand what Zeno was thinking about? Have you ever thought about why Zeno's arrow paradox still gets our attention after so long? Think about this: if at every moment the arrow is not moving, does movement really happen? It makes us wonder if time is a smooth flow or just a series of moments. Is movement something real, or is it about how we see time? Or is it a deep part of the universe that we do not fully understand?
That's an interesting idea, Michelle. Zeno's paradoxes are really confusing. In modern physics, like quantum mechanics, we see ideas like superposition, where a particle is in different states until we look at it. This gives a new angle on the paradox. Do particles not move until we see them? Or is motion always happening and we just watch it? The double slit experiment shows that looking at something can change how it moves, making us think again about time and space.
Exactly, Guy. Adding to that, high-speed cameras help us see motion in very small time steps. We see the arrow move from one spot to another, which seems smooth. But does this solve the paradox? Maybe these frames are single moments in a flow that our brains turn into movement. Our technology shows movement, but it doesn't fully explain why we see it as smooth.
That's a good point, Ryan. It makes us think about how we see time. What if each moment does not move, but our brains make it look smooth? Our minds can be tricky. Look at optical illusions. They show how our minds can fool us. Maybe Zeno's paradox shows our senses are limited, not reality itself.
Yes, and maybe Zeno's paradox is challenging us in a bigger way. If time and motion are ideas in our minds, are we just filling in pieces of what we don't understand? Could new quantum theories help us understand what Zeno thought of long ago? Maybe we need to change how we think about time. Are our new sciences getting closer to old philosophical ideas? Think about this idea: an arrow is flying but not moving. This is Zeno's arrow paradox. It asks if time is flowing or just still moments. This question has puzzled people for centuries. It makes us ask if movement is real or just how we see things. Could this show limits in what we know about the universe, or hint at a hidden complexity in time?
Really interesting, Michelle. Long ago, Zeno's puzzle connected to Greek philosophical arguments. People like Zeno questioned movement and continuity to find deeper truths. Today, quantum mechanics gives new ideas. For example, in quantum superposition, particles are unclear until we look at them. Could this be like Zeno's ideas, showing we're just starting to understand these concepts?
That's a great link to history, Guy. With new technology like high-speed photography, we see motion in very tiny moments. It makes it look like there is continuity. But does this tech just hide the paradox, or does it prove motion is ongoing, like Zeno questioned? Maybe our tech shows the problem instead of solving it by giving a fake answer through visuals.
You're touching on something important, Ryan. By breaking time into little moments, can our minds really make these into continuous movement? Theories like Gestalt talk about how perception fills gaps. Does Zeno's paradox tell us more about how we think than about reality? Maybe our minds create how we see motion and time.
Smart points. Maybe the philosophical meaning goes beyond physics and perception, shaking the core of existence. If time is in our minds, could new quantum ideas show hidden parts of Zeno's thoughts? As modern science meets philosophy, are we close to finding time layers beyond Zeno's imagination? Let's start our talk with this idea. Picture an arrow moving in slow motion. You see it in different spots, but not moving. Does this mean it never really moves? Or does it move in ways we don't get? Zeno's arrow paradox makes us question our understanding of movement and time. Can we trust what we see in the flow of time, or is it more complex than we know?
That's an interesting idea, Michelle. Ancient puzzles like this connect with today's science theories. In quantum mechanics, we see similar puzzles. Superposition makes us ask if reality is only real when we look at it. The double slit experiment shows that watching can change things. It suggests reality might need us to make it real, like Zeno's old questions. Do these ideas mean movement depends on what we see, like Zeno asked?
Exactly, Guy. New photography adds a new side to this puzzle. With high-speed cameras, we see every tiny move of an arrow. It looks like it keeps moving, but doesn't answer Zeno's question. Is this just our mind making things look smooth, or are our tools not good enough to show all of time's details? Maybe, like the mysteries in quantum physics, there's a truth we don't see.
Interesting point, Ryan. It reminds me of how our brain works with the Gestalt principle. It suggests our mind fills in blanks, creating a smooth motion from still images. Does Zeno's paradox test not reality, but our limits in seeing it? Does it mean our ideas of moving and time are shaped more by our mind than by reality? It seems our senses and mind together show motion, hinting at bigger truths of our world.
That's a strong idea, Sonia. Maybe Zeno's puzzle pushes us to look deeper into what we see. Could current quantum ideas like entanglement give clues to Zeno's old thoughts? If our senses aren't making continuity, maybe they are touching time's deep layers. Are we close to changing how we see time, maybe proving what Zeno guessed centuries ago? Think about this. In quantum mechanics, particles can talk to each other faster than light. This is called quantum entanglement. Does this show secrets about the universe that Zeno's arrow paradox hints at? What if time and movement are not as they seem? What about reality?
That's a good point, Michelle. Einstein called entanglement spooky action at a distance because it is so strange. Experiments show entangled particles act like they are connected, even if far apart. Maybe this means time is deeply connected. Could this be what Zeno hinted at but couldn't explain?
Interesting point, Guy. Fast cameras show moments that look like how entanglement links far results. For example, they capture the fast beating of hummingbird wings. But does this really solve Zeno's puzzle, or just show us pictures without explaining motion deeply?
Good point, Ryan. The Gestalt principles say our brain makes pieces into a whole picture. This means motion might rely on thinking, not just physical actions. Maybe Zeno's paradox shows the limits of what we see, not saying motion isn't real.
Great thoughts. Here's more to think about. If our brains make motion and time, could neuroscience show us new ways to understand reality? Maybe we are close to finding things Zeno only hinted at. Is time made by our minds, or part of something we don't know yet?
Going deeper, Michelle, new science can connect these ideas. Researchers study how the brain predicts movement by making future pictures before they happen. This might show why we see time as ongoing. Are we finding answers to Zeno's old puzzle?
Good question, Guy. There's also the debate about presentism and eternalism, seeing time as moving moments or a still timeline. Which one fits Zeno's arrow paradox? Do new scientific findings give us a clue which Zeno might have thought?
Good point, Ryan. It's important to see how these ideas go beyond what we can measure, questioning what existence really is. Could Zeno's paradox help us see time as only a part of a bigger, deeper reality?